Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module that is database design concepts, and the new chapter, that is chapter number 26, that is advanced transaction processing. That is, what are the various advanced features of the transaction processing, or what are the various advanced method by which we can do the transaction processing, in which we can obtain the content, in which we can do the content that is available in the data content, that is available in the database contents, that is used for.
वो हमने डाल दिया है, ठीक है, और वो इंस्टॉल हो रहा है। एडोब के अंदर आपको नेक्स्ट नेक्स्ट करना पड़ेगा, 5 मिनट लगेंगे, वरना वो ऑफिस हो जाएगा।
हाँ, निकल जाओ।
ठीक है,
ऑफिस हो गया।
हो रहा है।
अच्छा।
वो तो अपने आप हो
और
जाएगा।
एडोब
एडोब भी लगा दिया है मैंने, इंस्टॉल नहीं किया, वो नेक्स्ट नेक्स्ट करना पड़ेगा बस।
उसमें नहीं करना पड़ेगा ऑफिस में।
नहीं।
ठीक है, थैंक यू। So that is the advanced data processing, that is the transaction processing, that is how to make the transaction, or how to make the available transaction, that is advanced transaction processing. So let's start with the chapter. Let's start with chapter number 26. So in chapter 14, 15 and 16 we talk about we introduce the concept of a transaction, that is what is a transaction and how a program is able to access the transaction. Now the next part is advanced transaction processing, that is what are the various advanced features by which the transaction can be processed, that is advanced transaction processing. So in chapter numbers 14, 15 and 16 we introduce the concept of a transaction, a program unit that access and possibly updates various data information that is available, and whose execution ensures the preservation of the asset property, that is atomicity, consistency, isolation and the durability properties. We discuss various chapters for ensuring the asset property in the environment where failure can occur and where the transaction may run concurrently. So where the transaction may run concurrently, where the transaction or where the program may affect in a concurrent way. In this chapter we go beyond the basic schemes that is discussed in a previously and cover advanced transaction processing concepts that include the transaction processing monitors, transaction overflow, processing scheme that is available in the transaction. The first part is transaction processing monitor, that is what is the transaction processing monitor, that is a TP monitor, that are the system that were developed in the 1970s and 1980s, and is used to support a large number of remote terminals. So this means there is a client server approach, there is a server, there is a client, and the client requests for the services from the server, and server provides the services. That is a TP monitor, that is a system that was developed in the 1970s and the 1980s in response to a need of large number of remote terminals, that is for example in a airline reservation terminal from a single computer. The term TP monitor initially stood or initially used for the teleprocessing monitor that is used in the TP monitors, and TP monitors have since evolved to provide the core support for the distributed transaction processing, and therefore the term TP monitor has acquired its current meaning. So therefore TP monitor is derived from the IBM that is used, and the web application server architecture that also includes the servlets that we discuss in section 9.3, that includes the TP monitors and sometimes refers to as a TP Lite. And there are web applications that is used in the widespread use that is used for the TP monitors. Now first architecture is a TP monitor architecture, that is what is a TP monitor architecture. So the next is the TP monitor architecture, that is what is the architecture of the TP monitor, so that how to use the TP monitor and how to accomplish them with the use of TP monitor. So large scale transactions processing systems are built into around a client server architecture. So there will be a client server architecture that is used, that is processed in the TP monitor, that is run in the TP monitor, that is available in the TP monitor, that is used to reinstall the TP monitor, that is wait for the TP monitor. So that is a TP monitor that is used in the database management system, that is used to ensure that there will be a TP monitor that follows a client server architecture. One way of building such system is to have a server process for each client, that is server process is available for each client, that is used in the TP monitor, that is available in the TP monitor. So that is used in the TP monitor, and this is the process that performs authentication, authorization, then executes the action that is requested by the client. So there will be a TP monitor that executes the process, that follows the process for execution of the client. This process per client model is illustrated in 26.1a, and this model represents several problems with respect to memory utilization and processing speed. That is there will be a memory utilization, there will be a processing speed that is taken into account, that is a process per client model. And these are the various, or this model, or that this model is represented in the various program that is used in the various downloading process. So what are the various issues? First is per process memory requirement are high. So whatever the process requirement, whatever the memory requirement that is very high, that is used in the database management, that is used in the database architecture, that is used for the connection requirement, that is used in the database structures. So even if the memory for the program code is shared by all the processes, each process consumes memory for the local data and open the file descriptor. So whatever the file descriptor that is used, that is available in the database management, that is available in the database systems. Next point is the operating system divides up the available CPU time among the processes by switching among them. This technique is known as the multitasking. So there is also a TP monitor architecture that also includes the multitasking, that is more than one task is executing at the same time. That is a multitasking for the local data as well as for the operating system overhead, such as the page table to support the virtual memory. That is a multitasking, that is more than one task are executing at the same time, and that is available in the multitasking environment, that is available in the multitasking requirement. And the above problems can be, these are the two problems that is available that can be avoided by the having a single server of process to which the all the clients process. This model is known as the client server or single server model. This is the process per client model, this is a server model, this is a many server single router model, and then many server many router model. So these are the various models that is available in the database management system to solve the various issues, to solve the various requirement that is used in the various issues. So this is a TP model architecture in which there are many servers, there are many clients, and that is also known as a multi-threading environment in which we can support the hardware, we can support the software. And system based on the single server architecture, such as the original base architecture that can be used for the database management system, that can be used for the database management system. So that is the system architecture that is used in the database management system. And they had many problems. There are many problems. That is a single based application that is used, used in the database management system, that is around this. So what are the application, what are the various problem? The main problem is that there is no, we can say there is no browser, or there is no single processor, there is no protection against, there is no security among these ones, so that can be used in the various environments. So there is no security, there is no feature that is used in the environment of the database management system. And next problem that is used, that is such systems are not suited for the parallel or the distributed databases, since the server process cannot wait for the file, cannot do the file that is used in the database process, that is used in the many process that is used for the database management system. So that is also available for the database management system that is used in the database architecture. And such systems are not suited for the parallel or the distributed databases, since the server process cannot execute on a multiple computer at once. And one way to solve this problem is to run multiple application processes that access a common database, and to let the clients communicate with the applications through a single communications channel. So the main concern is that use the communication channel, use the model that is a single or many server single router model that is used, that is also defined in the 21.1.6. So this is the model that is used, that is a many server and the single router model. This is a single root, and these are the remote machines, these are the various servers, and these are the various files. and that is known as a multi-threading that is used with the database systems. And that model is known as a many process or many server to single server model that is used in the database architecture, that is used in the single router architecture. And this model supports independent server processes for multiple applications. That is further, each application can have a pool of server processes that is available in the database management system. And the above architecture is based on the web server that is used, that is HTTP request is used, that is HTTP form is used, that is available for the database management system. So there are many server single router process that is illustrated in this one, and this model supports independent tasks that is used with the various features that is used for the various we can say the versions of database management system that is available with the database applications. And the above architecture is based on the web server, and there will be HTTP request that assigns the task of the handling each request to a separate process, and each of the processes itself is multi-threading so that it can handle the multiple requests. And the use of the various or use of the safe programming languages that is available, such as the Java, C# or the Visual Basic, also allow the web application server to protect from the errors or protect the threads from the error. In contrast with the C or the C++ language, like C or the C++ error, such that is also available with the thread that is also available with the database architecture. So this is the TP monitor component. That is the next topic that is available in the next part, that is the TP components. More general architecture that has multiple processes, multiple processes that can be used rather than the processes, rather than just one to communicate with the clients. The client communication process interact with one or more routers or processes which route their request to the appropriate server. And the later generation TP monitor therefore have a different architecture known as the many server many router architecture that is represented in this one. So that is another architecture that is represented, that is many server many router, that is a multiple router and there are multiple server, that is a multi server and the multiple routers. And this is the architecture that is used, and the detailed structure of the TP monitor is available in 26.2 or 26.2. So this is the detailed TP monitor that is used. This is the network, and this is the input queue that is available, and this is the authorization, this is the log manager, recovery manager, log manager, database and the resource managers, output queue, application server. So these are the various server that is used in the database architecture that is used for the database applications. This is the application server. There will be output queue that is also available, and there will be log manager, recovery manager, and the log manager, that is a TP monitor component. And a more general architecture has a multiple processes rather than just one to communicate with the client. The client communication processes interact with one or more router process which route their request to the appropriate server. That is, the client request for the services, and services are provided by the server to communicate with the various routers or routers. Later generation TP monitor therefore have a different architecture that is known as the many server and the many router monitors. And the TP monitor does not simply pass a message to the application. So this role does not pass the application to the application server, but also handles the various tasks. When messages arrive, they have to be queued up. That is, they have to be in the line out so that it will be available in the database management whose entries survive them or survive system failures. And using a durable queue helps ensure that once received and stored in the queue, the messages will be processed eventually. That is, messages will be available eventually. That is available in the database management system to get the various installation, to get the various processes that is available in the database management. And finally, the TP monitor also provides the support for the persistent messaging. So any messaging that is available that is used for the management persisting, that is used for the management, we can see the database that is available in the database management system. In addition to this facility, many TP monitor also provide the presentation facility. So there will be a presentation facility to create the menus forms that is available in the database systems. So in addition to these facilities, there are many TP server that is used, that is available in the database management system, that is used for the TP server, that is used to create the menus form for the dump clients such as the terminal, and these facilities are no longer important since dump clients are no longer widely being used. Next is application coordination using the TP. Next is the application coordination using the TP monitor that is used. That is how to applications are interact with the TP monitor. So application today often have to interact with the multiple databases, or multiple databases that is available to interact with the databases, that is able to interact with the multiple databases. They may also have to interact with the legacy system such as the special purpose data storage system that is built directly on the file system. And finally, they may have to communicate with the users or the other application at the remote site. So whatever the remote site that is available, whatever the database that is available with the database management system that is used for the database concern, that is used for the database architecture. And they do not interact with the multiple databases. They may also have to interact with the legacy system that is used, that is available in the legacy found, or that is available in the legacy system that is used with the database management systems. So modern TP monitor provides support for the construction and the admin of the many data or many large applications that provide the support for the construction and the admin legacy system. So whatever the legacy system, whatever the database management system that is available in the legacy system for the communication, for the database management system that is available for the resource manager that provide the transaction control, that is the TP monitor, and there is an interaction or interface between the TP monitor and the resource manager is defined by a set of transaction primitive. So there are a set of transaction primitive that is used, such as the begin transaction, commit transaction, abort transaction, prepare to commit transaction, and the two-phase commit protocol that is also used for the database management system. And the resource manager interface is also defined, is also, we can say, the used with the database management system that is used for the database problem that is used with the database support. And there is a X open distributed system that is also available in the distributed manner, that is also available in the distributed essential that is used with the database management system. And there will be many TP monitor that is also used, such as the SQL system that supports the various TP monitor that supports the various cancel monitor that is used for the and in addition, services provide the TP monitor such as the persistent programming is also available with this one. And TP monitor can also be used to hide the database failure that is available with the database management system that is used in the database architecture, that is the database management system. And the request will be sent to the database management that is used in the database architecture, that is used for the hiding the database failure in the replicated system backup failure. In the client server system, client often interact with the server via remote procedure call. There will be RPC mechanism, that is a request, the remote procedure call that will be used to make the database availability, that will be used to make the database protection, that is used to where the client invokes a procedure call which is actually executed at the server. So there will be a client that invokes a procedure call that is actually executed at the server with the result that's sent back to the client. So whatever the client, whatever the database system that is available with the database architecture that is used for the database requirement that is used with the database processing that is used in the database architecture, that is RPC, where the client interact with the server with the use of the procedure call. So first of all, it invokes that is the client invokes a procedure call which is actually executed at the server with the result sent back to the client. So whatever the result that is sent back to the client, that is available with the database management system. As far as the client code that invokes the RPC is concerned, so whatever the RPC concern is available with the results, or the RPC is concerned, the call logs local procedure call invocation. And the TP monitor system provides a transactional RPC interface to their services. So there will be a transactional RPC interface that is available with the services, and in such an interface the RPC mechanism provides a call that provides a series of the RPC calls within a transaction. So whatever the transaction that will be available in the database management system. So next is the transactional overflow, that is how to use the transaction overflow, or what is the main concern between the transaction overflow. So next is the transaction overflow, that is what is how to flow the transaction, that is a transactional overflows that will be used in the database architecture. So a workflow is an activity in which a multiple task can be executed in a coordinated way by different processing entries. So whatever the processing entry that will be used, that is executed in a coordinated way by different processing entry that is used in the by which multiple tasks can be executed at the same time. So workflow is an activity in which multiple tasks are executed in a coordinated way by different processing entries. A task that defines some task or some work to be done and can be specified in a number of ways. So when we say about the task, that means that defines some work to be done and can be specified, that is how much time it will take, or in how many ways it will work, or how many ways a task will be, or how many ways a task will be finished, or that defines that can be specified in a number of ways, including a textual description in a file or the electronic mail message, a form, a message, or we can say other form that will be available on the computer program. The processing entity that performs a task may be a person or the software system, for example, a mailer, application program, or the database management system. So whatever the processing system, whatever the processing entity that is available that performs the task of the database management, that performs the activity of database management by which the transaction processing can be done, by which the transaction control can be done for the various operations that will be used in the database management system. And that performs the task, that may be a person or the software system that will be used, for example a mailer, application program, or database management system. And figure 26.3, this is given that example of some overflow or workflow, not overflow, it's workflow. So one is a workflow application, that is electronic mail routing. Then a typical task, that is what is a typical task that is used. Then the typical processing entry that is used in the typical processing way, that is used for the typical processing entries. So we can use the transaction processing, so we can use the transaction entries that will be available with the transaction processing. So first overflow is electronic mail routing, then the typical task is electronic mail message, and the typical processing entry is the mailer. So whatever the mailer, whatever the processing entry that is available in the workflow, that is available in the workflow activity. So a task that defines some work to be done can be specified in a number of ways, including the textual description in a file or the electronic mail message form or the computer program. And the processing entity that performs the task, that may be a person or the software system, for example a mailer, application program, or the database management system. Now next is the figure 26.3 that will be used, that is available with the, or that is the best example of the overflow, and the simple mailer system that will be used, that will be available in the database management system. And one of the example is the simply we can say the database, that is electronic mail, by which we can send the data, or we can send the email from one part to the another part. Other term that is used in the database system, that is related to the database systems, that is related with the culture and to refers to the workflow that is used, that includes the task flow or the multi-system architecture applications. And workflow tasks are also sometimes known as the steps. So whatever the work task that will be used, that is known as the steps, that will be used to process the steps. In general, the workflow that is used, the workflow that may involve one or more humans. So whatever the workflow that will be used, that may include the human, that is used to include the human beings, that is satisfy the human beings. Whatever the entity that is available, that will be available in the human beings, or that is available with the human beings. And the person who wants to loan fill out a form which is then checked by the loan officer. So this is just the overflow that also contains, or that may also contains one or more human. For example, if you want to take the admission in the Pearson, first of all you register with the admin, then faculty will be available, or faculty will be allotted to you. That means there are various steps that contain the overflow steps. And when all the required information has been collected, the loan officer may decide to approve the loan. That decision may we can say that decision they have to be approved by one or more senior officers. So that is a step, that is the different steps is available, that is used for the various customers. So this is first of all the loan application, customer request for the loan officer, loan officer do the verification. After verification, supervisor could it contact to the supervisor officer, then again go to the loan officer, then accept loan reimbursement, then available to the customer. And if the verification is not satisfied, then it will be rejected and it will be returned to the customer. And each human have performs a task. For example, in a bank that have not automated the task of the loan processing, the coordination of the task is typically carried out by passing the loan application with attached note and other information from one employee to the another. So whatever the employee, whatever the security that is available, that will be available in the database and management system. And the other examples of overflow include the processing of the expense voucher, of the purchase order, or the credit card transactions. Now today, every information that is related to the workflow that is used with the database management system, that is used with the database entity, that is used with the database architecture. So there will be workflow, that is today all the information related to the workflow is more than likely to be stored in a digital form on one or more computer. And with the the growth of the networking, information can be easily transferred from one computer to the another. So the information can be easily transferred from the one part to the another part, and it is feasible. Hence, it is feasible for the organization to automate their task. So it is feasible for the organization to automate their task. That is how to automate their task, and what is the rule for the automating the task that is used for the database management system. And the workflow itself then involves handling of the responsibility from one human to the next, and possibly even to programs that can automatically fetch the required information. And humans can coordinate their activities by means such as electronic mail. That is, humans can coordinate with itself by using their ways that is used for the various files that is used with the database management system. And workflows are becoming increasingly important for the multiple reasons within as well as between the organization. That is a workflow that is available, and many organizations today have multiple software systems that is used that need to work together. So there are multiple organizations that is used that contains a multiple software system that need to work together. For example, when an employee joins an organization, information about the employee have to be provided to the payroll system, to the library system. So there are multiple places to which the multiple, we can say, the information about the files can be uploaded, can be updated to the various departments. That means also a workflow that is used, that is, the work will be available to the one or more places. And organizations are increasing automatic their services. For example, a supplier may provide an automated system for the customer to place the order. So now everything is become automated, that is available in the digital place, that is available in the digital manner. And several tasks may need to be carried out when an order is placed, including the reserving, production time, to create the order process, to create the process, that will be available in the database management system, and also the delivery services to deliver the project or product. And we have to add two activities in general to automate a workflow. One is the workflow specification that details the task that must be carried out and defines the execution requirements. So whatever the task, whatever the defined, first of all define the task that is to be carried out, and then define the various execution requirement, that is what are the various requirements that is used for executing the task or for executing the task. So what are the various requirements that is used. And we must to provide the safeguard of that additional database system that is related to the computation correctness and data integrity and the durability. For example, it is not acceptable for a loan application or a voucher to be lost or to be processed more than once because of the system crash. That is, everything is digital, everything is become digital that is used in the system crash. And the idea behind the transactional processing or overflow workflow is to use and extend the concept of transaction to the extent of the overflow that is used in the database management system. And both the activities are complicated by the fact that many organizations use several independent managed information processing systems. Now next is the overflow specification, that is what is the overflow and how to specify the overflow, how to specify the workflow, that is a workflow specification. So internal aspect of a task do not need to be modeled for the purpose of specification and management of workflow. In an abstract view of task, a task may use the parameters stored in an input variable, may retrieve and update data in the local system, may store its result in its output variable, and may be queried about its execution state. So whatever the execution state, whatever the query that is given, that is available in the execution task. At any time during the execution, the workflow state consists of the collection of the states of the workflow constitutes task. So whatever the task, whatever the activity that is available in the activity, and the states that is used of all the variable in the workflow specification. The coordination of the task can be specified either statically or the dynamically. So whatever the coordination, whatever the task that is available, that is done either the statically or the dynamically. A static specification defines the task that is available in the database management system that is used with the database management system, that is used with the database architecture or the process architecture. And the static specification that define the task and the dependencies among them for the execution of the workflow begin. And a generalization of this strategy is to have precondition for the execution of each task in the workflow, so that the available or the possible task in our flow and their dependencies available. And the preconditions can be defined through the dependencies such as the following. So these are the preconditions that will be used, that will define the task in the pre-processing environment. So these are the preconditions. One is the execution states, that is of other tasks. For example, the task Ti cannot start until the task Tj has ended, or the task Ti cannot work, that is the task Ti will be ended. Then output value of other task that you will use. For example, Ti can start if the task Tj returns a value that is greater than the 25. Then external variable that is modified by the external events. Now next is the failure atomicity requirement of the workflow. So whatever the execution, whatever the we can say the failure that is available, that is how to contain or how to control the failure that is available in the database management system. That is the failure atomicity requirement of a workflow. Let's take a break for 2 minutes. Then after the break, let's move to this one, failure atomicity requirement. So the next part is failure atomicity requirement of overflow. That is what are the various failure atomicity requirement. That is what is the requirement of the failure, what is the requirement of the workflow that is available with the failure atomicity. That is the failure atomicity requirement of the workflow. So the workflow designers may specify the failure atomicity requirement of the workflow according to the semantic of the workflow. So whatever the semantic, whatever the usage that is available, that is used with the sequential access, that is used with the sequential scenario, that is used with the various sequential manner by which the workflow can be used, by which the workflow can be handled. That is the failure atomicity, that is how to use the or how to detect from the failure atomicity, that is the failure atomicity requirement of the workflow. So it is according to the semantic of the workflow that is used, and the traditional notion of a failure atomicity would require that a failure of any task result in the failure of the network. So if there is any task fail, so the requirement of the network or the whole network will be failed. That is atomicity of the requirement. So however, however, a workflow can in many cases survive the failure of one of its tasks. For example, by executing a functionality equivalent task that is used that is available in the task that is available at the another side. Therefore, we should follow the or allow the designer to define failure atomicity requirement of a workflow. The system must guarantee the very execution or every execution of the workflow that is terminated in a state that satisfies the requirement. And what are the various states by in which the terminated requirement is accessed? That is acceptable terminated sites of a workflow. All other execution of a workflow constitutes a non-acceptable terminated site in which the failure atomicity requirements may be violated. An acceptable termination state can be designated as the terminated or the committed. So we can either use the committed word, either use the automatic word, either use the committed word that is used for the transaction process. So there is a committed acceptable termination state is an execution state in which the objective of the workflow can be achieved. So whatever the workflow that will be used, that is used for the various achieved, that is system failure that is used with the various achieves. And there will be aborted acceptable termination state also, that is whenever the termination will be aborted, so there will be aborted termination states that will be used for the termination. And if the aborted acceptable termination state have been reached, all the undesirable effects of the partial execution of the workflow will be or must be undone in accordance to the in accordance with the that workflow failure atomicity requirement. So whatever the requirement of the atomicity that will be used, that will be available with the various atomicity problem that is used with the various atomicity failures. Now, a workflow must reach an acceptable termination state even in the presence of the system failure. So, whatever the system failure that will be available, that is used in the system mode, that will be used in the system failure, that will be available for the system database. And if the workflow is non-acceptable termination state, that is at the time of failure during the system recovery, it must be brought to the acceptable termination state, whether the aborted or the committed. For example, in a loan processing over workflow, in the final state, either the loan applicant is told that a loan cannot be made or the loan is disturbed. So we can either use the loan is made or the loan is disturbed. But in case of a failure, after a long failure of a verification system, the loan application could be returned to the loan applicant with a suitable explanation, and this outcome could constitute an aborted acceptable termination. So whatever the application terminal, whatever the content that will be used, that will be used in the application development. And in general, a task can commit and release its resources before the workflow reaches the terminator state. So whatever the termination state that will be used, that will be reached to the termination process. And system may require the undo process that will be undone in the undo process. And in an expense voucher processing overflow or workflow, for example, a department budget balance can reduce the balance of the execution. Now next is the execution of the workflow, that is how to execute the workflow requirement or how to execute the workflow content. The execution of the task may be controlled by a human coordinator or a software system known as the workflow management system. So whatever the execution of the task, whatever the execution that will be available, that will be controlled by the human coordinator or by the software system known as the workflow management system. That is the workflow management system. And the workflow management system consists of a scheduler, task agent, and the mechanism to query the state of the workflow system. So workflow management, that is how to manage the workflow, that consists of the workflow manager, that consists of the scheduler, that consists of the task agent, and the mechanism to query the state of the workflow systems. And the task agent controls the execution of the task by processing entity. And the scheduler is a program that processes the workflow by submitting various tasks for execution, monitoring various events, and evaluating the condition that is related to inter-task dependency. That scheduler may submit a task for execution or may request that a obviously or previously submitted task must be aborted. In the case of multi-database transaction, the tasks are sub-transactions and the processing entities are local database entities that will be available that will be used in the workflow dependencies. And there are three architecture approaches to the development of the workflow system. There are three architecture processes that will be used in the development of the architecture that is used. And the first architecture is the centralized architecture, then there will be a partially distributed architecture, and there will be a fully distributed architecture. So one is a fully, one is a partially, one is a centralized architecture. And the simplest workflow execution system follow the fully distributed approach that described and based on the messaging. Messaging may be implemented by persistent messaging mechanism to provide guaranteed delivery. And some implementation use email for messaging, and such implementation may provide the features but they do not guarantee atomicity of the message delivery and the transaction commit. But generally do not guarantee atomicity of message delivery and the transaction commit. The centralized approach is used in the workflow systems where the data are stored in the central database. So whatever the centralized approach, that is a workflow system where the data can be stored in a centralized location. So there will be a central database that will be used to central location that will be used for the central database that is used for the centralized data, that is central database. And the scheduler notifies various agents such as the human or the computer program that the task could be carried out and the keep track of the task completion. So whatever the task completion that will be used, that is used with the database architecture. The scheduler must guarantee that the overflow will terminate in one of the specified acceptable termination state. Then recovery of a work. One important thing is that safety checks such as the one that described may be impossible or impractical to implement in the scheduler. So whatever the task that will be used that is improper or in an improper way, that will be used in the improper manner, that will be used in the improper content, that will be used in the improper manners. So next is the recovery of overflow. That is how to recover from the workflow. That is a recovery of a workflow. So the main objective of workflow recovery is to enforce the failure atomicity of the workflows. That is, the failure atomicity will be provided to the workflow. That is, so that the failure will be used, so that atomicity will be oblique, or we can say used for the database administrator. And the recovery procedure must take sure if a failure occur in any of the workflow processing component, including the scheduler, the workflow will eventually reach an acceptable termination state, whether the aborted state or the committed state. For example, the scheduler should continue processing after the failure and recovery as though nothing happened. That is, the scheduler will always do the task. It treat like nothing will happen, nothing will do the activity, nothing will available in the activity. That is, there is no available activity. And we assume that the processing entity involved in the workflow have their own recovery system and handle their own locality or their own facility or their own failure. So whatever the failure that will be used, that will be local to the failure, that will be local to the various database systems that will be available in the database administrator. Then next is the workflow management system. That is what is the workflow management system, how to use the workflow management system. That is the next part. So workflows are often hand coded as a part of the application systems. So the next topic is workflow management system. That is how to manage the workflow. That is a workflow management systems. So workflows are often handed or often coded as a part of the program, that is as a part of the application system software that is used. For example, enterprise resource planning, that is a ERP system that will be used, that will help the coordinate activities that is used. that is used to various activities that will be available in the database management system, that is used to coordinate the activities, that is the ERP. And the goals of the workflow management system is to simplify the construction of the database system, that is how to simplify and use the simplification process by which the simplification can be done. And the goal of the workflow is to simplify the construction of the workflow. So whatever the workflow that is used to simplify the process of the workflow and make them more reliable, and make them more reliable means make them compatible by pertaining them to a specified in a high level manner and executing in accordance with the specification. So whatever the specification that is used, whatever the condition that will be used, that is available in the database management system. And there are a large number of commercial workflow management systems that are generally special purpose management system, while the other are specific to a workflow, such as the order processing or the bug failure report processing that is will be used. And the term business management or the business process management is used to refer to the management of the workflow that is related to the business processes. So whatever the business processes that will be used, that is related to the business processes. Today the applications are increasingly making many their functionality available on the services that can be invoked by other applications. So whatever the other application, whatever the application that will be used, that is used for the system shutdown or that is used for the system failure, that will be used. And sometimes the applications are known as a system or service oriented architecture, SOA, and such architecture are the basic layer on the top of which management or workflow management is implemented today. And the process logic that controls the overflow by invoking the transaction, by invoking the services, that is known as the oscillation. So whatever the oscillation, so what is the oscillation? That is the process that by which the overflow can be controlled. Overflow contains the activity by invoking the services, that is known as the orchestration. And the web service business process execution language, that is the WSBSL, is an XML standard language for the specifying the web services and the business applications. Now next is the e-commerce that we have already studied, that is what is the e-commerce. Then e-catalogs, marketplace, we have already studied this. Order statements, we have already studied this. Then next is the main memory database. That is the next topic that I'm going to start in the Monday's class. So that's all today's session. In the Monday's class, I'm going to start with the next topic, that is main memory database. So that's all today's session. Thank you so much everyone for listening me. If there is any doubt, any suggestions, you can ask the doubts from me. Thanks a lot everyone. Bye bye.